Hello students, so today I am deliver the lecture about the CMOS logic gate circuits. So in basically the CMOS, it is the complementary metal oxide semiconductor transistors. So according to the combination logic, the output of any time is a function of the only input values of that signal at that time. So they don't have any memory and feedback, and the large rotary they have also used large in a large way in the digital circuits. And the CMOS steady gates basically are used in complementary form like NMOS and PMOS, which is used by the driving input functions of 0 and 1. So basically, when we talk about the NMOS transistors, which is basically provides more current than the PMOS transistors with the same size and capacitance. So NMOS networks are preferred compared to the PMOS networks generally, and the combination of both when we use the inverter, where we, according to that in the inverter circuit we have used the one PMOS transistor NMOS transistor, which is we have taking the capability as a driven function of input 0 and 1. At 0 it is driven the PMOS transistor, and as an input is 1, then it is driven the NMOS transistor. According to that we have taken the output according to what we have given in the input of the inverter circuit. So basically, when we talk about the drawbacks of CMOS, it requires both PMOS, and NMOS transistors on each input. In static CMOS, all the node voltages must have transition between the 0 and VDD. And static CMOS logic is popular because of its out robustness. In basically circuit families, static CMOS circuits with complementary NMOS pull down and PMOS pull up networks. Basically, NMOS work as a pull down network and PMOS work as a pull up network. When giving the input at the gate inputs of the common node, and we take on the drain outputs of the common node. So here we are talk about the advantages. They have good noise margins, fast low power consumption in on state, insensitive to device variations, easy to design, and they are widely supported by CAD tools, computer aided design tools, and they are readily available in standard cell libraries, because they all are available in different type of libraries, in different type of software, different type of basically the schematic design and logic design circuits, and different type of Tanner tools like Tanner tools, different type of cadence, synopsis, and the library of these all things are available in the form of different types of devices like PMOS, NMOS, supply, ground, inputs, output, different type of input variable, and different type of variable outputs according to we have given the input. So pull up when we take the pull up networks, that is basically constructed by the PMOS transistors, and we talk about the pull down networks, which is basically constructed by the NMOS devices, and according to that we have taken the output according to whatever input. So in this diagram I will show here the pull up networks, which are basically the PMOS transistors, and pull down networks, which are consist of NMOS transistors. Here we use the three inputs A, B and C as giving same inputs at pull up network and same inputs given the pull down network. Upper part we have supplied VDD supplied, and lower part of the pull down network we have supplied ground output, and in between them we have taken the output in terms of Y. That depends on what we have given in the input. Suppose in particular network we have taken the CMOS inverter. So in CMOS inverter, one PMOS transistor given a single input, suppose you have given input is 0. So in pull up network basically PMOS transistor is there, and in pull down network basically NMOS transistor is there. So according to that, when we giving the 0 input, and from 0 input basically pull up network PMOS transistor is activated. So according to that pull up network basically it is work on 0. So it is weak 0 and weak 0 and strong 1, means when we provide the 0 input, so it is without any log, it is giving in output 0, but when we provide the 1, then we have reduced the output in terms of input. So in the same thing when we talk about the pull down network and we use the NMOS transistors, so in NMOS transistor it is working on an so weak 1 and weak one and strong 0, means we have given input 0, then same the output we have achieved the output, but when we give the 1, then we have take the output VDD minus V threshold value, that is in V input, that is basically we have divided the we have subtract the threshold value from the input value we are taking in the output. So according to that pull up and pull down network, when suppose we have taken the example of CMOS inverter and we provide a single input A in terms of 0 and 1, according to that we have taken the output. Suppose we have given input in 0, so pull up network like PMOS transistor activated, and at the same time pull down network NMOS transistor is basically switch off. So according to that 0 network, the upper part means PMOS transistor is activated according to 0 input network, and output is supplied to basically high. So it is VDD supply basically high to this pull up switching network, that is PMOS transistor, and at the same time pull down network is an off switch. When we provide the input as an high level, one input level, so at one input level our pull up network basically it is a 0 position, it is a switch off condition, and from one pull down network is activated, so the output node is switching towards the ground, means we have given the output, then output node is given to the ground, means we have given the input 1 and taken the output in terms of 0. So pull up means taken the pull up in high value, and pull down network taken the value to down value. So this is called the pull up and pull down network, where we are given the input and taken the output according to the input conditions. So in these conditions basically I have talked about the in terms of pull up and pull down network, basically only one of only one of pull down and pull up network is on at a single given time at the combination of the input signals, and the pull down network is constructed using NMOS and pull up network is constructed using the PMOS. For an input design, the number of transistors required is 2n. Suppose I have a design here the 2 input NAND gate. So only I have designed the NAND gate. So in NAND gate, according to the input, when we provide the single input, so 2 transistors are present there, one pull up transistor, that is PMOS, and one pull down transistor, that is pull down. Suppose we have provided the 2 input NAND gate, so in this condition we have 2 upper part pull up transistors, that is PMOS, combination of PMOS, and 2 pull down network transistors, that is a combination of NMOS transistors. So n input 2n transistors are present for the particular defined logic. So the output is always as a low impedance state connected either VDD or ground. There is no direct path between the VDD and ground in the steady state condition, static power dissipation was there, and the pull up and pull down network, suppose we have given VDD is high in terms of input, so NMOS is activated, output is 0. Suppose we have given input 0, PMOS network, pull up network is on, so output is high at the 0 condition. So when we give the 0 VDD, provide the output in VDD, and we have given the VDD input, NMOS transistor activity pull down network, and we have taken the output in 0. So according to that, when we taken about the pull up and pull down combination, so in this case we have generally studied about the series and parallel combination of the PMOS and NMOS transistors, that is in connected in series fashion or in parallel fashion, depend on different type of conditions. Suppose we taken about the pull down network condition, so parallel to form OR function and series to form AND function basically. Suppose we have considered here the pull down network of NAND transistor. So when we talk about the NAND means our NMOS transistors which are situated at pull down network. NMOS transistors are constructed the down network. Pull down network means NMOS transistors in down fashion. Means when we talk about the NAND gate N plus AND means NMOS transistor are in AND function. AND function means NMOS transistor are in series function. So here we take the example, suppose A or V is our input, VDD and supply, towards we have get the output in terms of series fashion of these input A and B input transistors. 2 transistors are in series fashion in down network of NMOS transistors. When we talk about the upper part of that, because it is a combination, so according to that the parallel to form AND function and series to form OR function, that is just in opposite way. So our PMOS transistor, that is our pull up network, so in this case our pull-up network, that is parallel. Parallel means we have taken about just opposite of that. Suppose n transistors are in series fashion, then in a parallel way PMOS transistors are in parallel, and suppose we have taken the NMOS transistor in on fashion, then PMOS transistor is in n fashion in that particular way. When we combine the both groups, pull up and pull down network, then finally we have considered the single input, a single output, or two input or three output according to network input conditions. We have taken the output according to that. So suppose according to that we have taken the different type of input and output networks. Suppose at the same time when we talk about the NOR gate function, in NOR gate n plus OR means NMOS transistors are in OR function or in parallel function, means both the transistors are in parallel function, and the same time pull up network, that is in just opposite of that, in series function. That is the diagram of the pull up network of the NOR gate. So when we combine both the gates, then we finally taken out the output in terms of the input. Here we have taken the example of NOT gate in terms of PMOS and NMOS transistor. So I have already talked earlier that when we given the input A and taken the output in terms of power function, means output in terms of high, low, high, high, low, 0, 1, 1, 0. So that is the combination of that is a particular combination logic of the NOT gate. So here I will taken the diagram, upper part pull up network, that is PMOS transistor, and lower part, that is basically the NMOS transistor. We have given the input in terms of both transistors gate input, and we take out the drain of both source gate drain, drain gate source, and we have taken the output of the drain of the two transistors, that is Y is equal to A bar. A bar means A output 0, A bar 1. When again A is input is 1, output is 0. Suppose here when we talk about the more conditions, that shows the two input NAND gate. NAND gate means NMOS, N plus AND means our NMOS transistor, that is pull down network, is in series fashion. Suppose A or B is one input, two input NAND gate, then drain gate source, drain gate source, that are basically in series fashion, and the PMOS network is in parallel fashion. Source gate drain as a parallel with source gate drain with the connected with supply, upper part VDD and lower part is connected to the ground supply. So that is the combination of NAND gate A into B bar. Suppose A into B our is input, then NAND gate and A into B, and NAND means just NOT gate of it, means A into B bar, that is our two input NAND gate combination. Here we will have shown here the three input NAND gate. A into B into C means that three input are there, A, B and C. So N plus AND means three AND gates are basically in series fashion. Drain gate source, drain gate source, drain gate source, that our NMOS lower part, A, B, C was input, that is the lower part, that is combination of A into B into C, and upper part pull up network, that is just opposite of it, N parallel function. Source gate drain, source gate drain, source gate drain, A, B, C our is input, that is our part, and we have taken the output in terms of that A into B into C into whole bar. So that is the sequence implementation of the three input NAND gate. Suppose we taken about the NAND gate. Suppose when taken input in terms of a truth table 0 0 0 1 1 0 1 1, then AND gate 0 0 0, NAND gate 1 0 1 0 1 1 0 0 1 1 1 1 0. So that is just opposite of the interpretation of the AND gate 0 0 0 1, then AND gate is 1 1 1 0. Suppose we have taken the example in terms of how can it is work in terms of input and output. Suppose we have taken the first example of truth table 0 and 0. So according to the when our input is A and B is equal to 0, then according to that we have done the circuit of two input basically NAND gate. So in this case when our A 0 0, A and B both are 0, so when we take the two input according to it A and B is 0, so in upper part and in terms of lower part, upper part is our pull up network and lower part is a pull down network. So when we given in terms of A and B both our inputs are 0, so lower part is basically the our series combination of the NMOS transistors, and NMOS transistors basically when given A part is 0, so NMOS transistor in off condition. So when it is an off condition, lower part is cut off. But when we talk about the upper part where we use the PMOS transistor, and when we given the input as 0, then our upper part is activated. So both the transistors are on. So it is pull up the network to the high position towards the VDD. Means when we talk about the two input currents of both the transistors, suppose I1 is the PMOS transistor due to the switching condition of the first transistor, that is the non condition, and I2 current is in the second condition. When we provide the B input, then both the transistors are in parallel fashion, then it is a total current from VDD to upper part, that is I1 plus I2, and we get the VDD in the output. Suppose at a one part when we provide the A is equal to 0, B is equal to 1. So in this example, basically when we provide the A is equal to 0, upper part of PMOS is 1, current I1 is flow. But in lower part we talk about the A is equal to 0, one transistor we given input but is in off condition, so only one transistor is activated and we are take the output in VDD form. Just opposite of it, when we take at the A is equal to 1, B is equal to 0, so one PMOS transistor is on, upper part is high, and we have taken the A is equal to 1. Suppose one transistor is on but the second transistor off is condition, both the transistor is in off condition, but due to that when we provide the A is equal to 1, B is equal to 0, then B is equal to 0, one transistor is activated, one transistor is off. So when one transistor is activated, VDD is supplied to ground, and A is equal to 1, B is equal to 0, A is equal to 1, the one transistor NMOS transistor is in on condition but the second transistor is in off condition, that is cut off condition, that is output we have taken the VDD form. When we take the both inputs are in one form, so in lower NMOS transistors, both NMOS transistors are on condition and both upper PMOS transistors are off condition, and output is towards the ground position, towards the 0. So that is in this condition I will taken here the example A is equal to B is equal to 0. What are the condition of PMOS and NMOS transistors on and off? According to our we have taken the output. So it is the combination of three input NAND gate conditions, where is in series condition in NMOS transistors and parallel condition of the PMOS transistor, that is the combination of three input NAND gate transistors. At the same time when we talk about the NOR conditions, so NOR conditions here when we talk about the two input NOR gate, so N plus OR means NMOS transistor in parallel function, so upper down part is the parallel function, upper part of PMOS transistor is in series condition. So when we talk about the A is equal to 0, B is equal to, both are 0 condition, so both the transistors when we talk about both the transistors series fashion, both the transistors are in on condition, so upper part is supplied toward a VDD, and lower both the transistors are in parallel function, both are in parallel function but both the transistors are in off condition, so this is the output is towards the VDD. When we taken the A is equal to 1, B is equal to 0, when we take it A is equal to 1, upper part of transistor is off, but when the transistor is off, so there is no value. But when we take the lower part, that is both the transistors are on, so in the case both are in parallel function. When we suppose A is equal to 1, B is equal to 0, so one transistor is on, NMOS transistor is on, and it is lower towards the ground, so output is 0. At the same time A is equal to 0, B is equal to 1, same condition is there, per part one transistor is on, one is on PMOS transistor, one is NMOS transistor is off, one is transistor on, so one transistor is on with parallel function, so output is towards the ground condition. But when both the input transistors are in A is equal to B is equal to 1, so in this condition both the transistor PMOS transistors are off, so it is a cutoff condition, but both the transistor is on, so it is towards the ground, so towards the output is 0. So according to the NOR gate conditions, what are the A is equal to B is input and 1 0 0 0 in output according to 0 0 0 1 1 0 and 1 1. So that is the combination of three input function of the three input NOR gate. NOR N plus OR means both three transistors PMOS NMOS transistors are in parallel function, and upper part PMOS transistors are in series function. So that is the combination of three input NAND and NOR gates. According to that, so when we talk about the CMOS AND gate and OR gate, so according to that when we take about the AND and OR gate, so two input NAND gate and we have taken the output towards the input of the one NOT gate, then we take the output in terms of the AND gate. At the same time when we talk about the NOT transistor, two input NOT transistor, and we taken the output two input NOT transistor output to NOT gate, and we taken the output in terms of OR gate. So when we adjust the output of the NOR gate towards the input of the one NOT gate, and we have taken the output in OR function, and we taken the T input and AND gate as an input towards the output of the NOT gate, they have taken the output of the AND gate. So these are the CMOS and AND gate, OR gate. These are the according to the PMOS or NMOS transistor according to the new fashion. Okay, thank you.